Hello again. Today we're going to discuss a mathematical methods question. So we are talking about Unit 3. It's integration question. So topic is area between curves. So this is a complex, unfamiliar question. So let's have a look. Question. So we need to determine a line, linear equation, y equal to mx, so that this divides the area under this curve. So we've got two curves. So let me highlight those two curves. So one is y equal to ms. So these are straight line. The other one is parabola. So over this between 0 and 2 into two equal area. So in order to solve this question, so we need to find the straight line y to mx. So that means we need to find out what is m. So to determine the straight line, so we need to find what is m. So we need to find m equal to. So this is our question. So we're given those two conditions. So how we solve it? So before I do it, let's put a perspective. So we need to put it into a graph situation so we can see what is the area between the two curves. So let me draw a graph. In order to draw the graph, I needed to solve first. I need to draw y equal to 2x my bracket 2 minus x. So let's draw this graph first. So when we sketch the graph, so we need a x-intercept and y-intercept. So we know the x-intercept, in this case, very easy. So x-intercept will be x equal to 0, and the other x equal to, so x2. Sorry, just a little bit, turn out a little bit. So let's work it out. All right, so the x1 is 0, x2. So x2 is 2. So that's x1. So we got x-intercept, y-intercept is y-intercept is also 0 and 0, because you can see this x. So we draw the graph. So I'll make it sketch the graph for the parabola. So x-intercept 1 is 0, 1 is 0, 1 is 2. So that's parabola. So this is the first graph. So y equal to 2x, 2 minus x. So next one is second graph. We need to draw is y equal to mx. Now because we don't know what's the gradient, so we don't know the m, but we know that this is straight line. Also, this is passing 0 and 0 as well. So the x-intercept and y-intercept is also 0 because of its origin. However, if I say, okay, because we don't know what m is, so we don't know the slope, so but we know this gradient straight line would divide this whole graph, whole area into two equal parts. So that means this half, will be half of the total graph. So this is the total graph, but this will be half of it. But what is the total graph under this curve? So under the y equal to 2x bracket 2 minus x. So first of all, we need to find the area under y equal to 2x bracket 2 minus x. So if we do that, so we needed to do integration. So let's do that. But before I do that, I'll just simplify this equation, expand the bracket to 2, so it becomes 4x. Sorry, just fill up a little bit. Expanded brackets will be 4x minus 2x squared. So let's do the area. So the area equal to from 0 to 2. So area between 0 and 2. Bracket 4x minus 2x squared dx. So the answer will be, so let's do the integration. So it'll be 2x squared minus 2 over 3 x to the power of 3 minus 0 to 2. So this is the area between under the curve. So now we substitution. So we put 2 substitutes. So 2 times by 2 squared minus 2 to the power of 2 to the power of 3. And minus, obviously, the next one will be 0. So it will be equal. So we ignore the zeros. So it will be, so this could become 8 minus 2 divided by 3 to so this is 8. So the answer will be so 8 divided by 3. So this is the area under the curve of the parabola. So not the between the curve. However, we know this area, if I call area 1, this area 1 is area between the two curves. So area 1 must be half of the total area. So which is the area of this. So area 1 will be half of 8 divided by 3, so it will be 4 divided by 3. So this is the area 1. Now, we're going to use the integration to find the area 1. Before we do that, we need to say area 1 is the area between two curves. So in order to find the area between two curves, we need the intersection point, which is, we don't know what x is, we don't know what y is, but mainly we need x. So that's the pretty point. So what do we know? What's the x? So we know the x is determined by the simultaneous equation. So in order to find that intersection point, so we need to combine the two equations together. So we do so establish the two linear equations into simultaneous equation. So we call y to mx, which on the so the equation and join with the parabola. So we call equation 1 and equation 2. So we solve them simultaneously. So mx substitution method. So we move our things around. So it becomes 2x squared plus m minus 4 x 0. So x1 is 0, we know that. Second one is 2x plus m minus 4 equals 0. So x will be x2 will be 4 minus m divided by 2. So that's the x2, which is this one. So which is this the x2. So x2 is 4 minus m divided by 2. So we got that. Now we can use area between curve. So we call area 1. So we can use area between curve is from 0 to x2, which is 4 minus m divided by 2. So we use the top curve, which is 4x minus 2x squared. So that's the parabola. And minus mx, which is linear equation. So we solve the gateway between curves. So let's simplify 2. So we divide by 2. So this will become 4x. How do we use? I'm going to isolate. Isolate. So collect those two like terms together. So we know 4m x and then minus 2x squared. So simplifying the bracket. So we got, so now we integration. So the first one, so 2 to the power of 2 minus, so then 3 underneath, so x to the power of 3 from 0 to 4n divided by 2. Okay, so substitution, so we 4n. Now we have a substitute to that, so it becomes square, and put it together, become cube. And underneath, because we got 2 here, so we put it into square, so it'll be 2 times 4 will be 8. And then this one be the same, so 2, 4 minus n to the power of 3. The bottom number 3 is already there, so over here will be 8. And the rest will be zeros, so we don't need to consider, so we equal. We cancel these 2, become 4. So the final answer will be 4 minus n to the power of 3 divided by 8. And that will be 12 bracket 4 minus n to the power of 3. So we join together. So the common denominator will be 24. So there will be 3. And this will be 2. So the answer will be 24 over, so 4 minus n. Sorry, this will be 3. Okay, so this is the area 1. So that because we know area 1 already, we calculate about half of the total area, so which is 4 over 3. So therefore, we will have 4 minus m divided by 24 equal to 4 over 3. So we cancel it out, so there'll be 8. So now we can solve for m. So 4 minus m to the power of 3 will be equal to 32. So therefore, 4 minus m will be cubic root of 32, which is cubic root of 8 times by 4. So 8 is 2 to the power 3. So we can move 2 out. So we become final, maybe this really right here. So that 3 will be smaller. All right, so we put the cubic root on the top. So this is our 4 minus m. So therefore, our real m will be 4 minus 2 cubic root 4. So this is our n. So therefore, our linear equation y equal to mx equal to bracket 4 minus 2 x. So this is our linear equation. So we solve that. Then you can substitute that to the equation to see if that's right. So to verify your answers. That's it. That's our solution for today. And if you like this YouTube video, you can subscribe to my channel. Thank you again. Bye-bye.